thought I would do one additional interval convergence problem. This is actually the e to the x definition, x to the n over n factorial. So I wanted to look at this. We want to look at the limit as n approaches infinity of the n plus 1 term. So it would be x to the n plus 1 over n plus 1 factorial divided by the nth term, which is x to the n over n factorial. We're taking the absolute value of that whole thing. That's the same thing as the limit as n approaches infinity of x to the n plus 1 over n plus 1 factorial. And then you're multiplying by the reciprocal. So you've got an n factorial and you've got an x. And anyway, if you do a little simplifying here, you get limit as n approaches infinity, and you can kind of group things. You've got an x to the n plus 1 over an x to the n, sorry, I lost that n there, being multiplied by an n factorial over an n plus 1 factorial, okay? And so what's going to end up happening here is you're going to get a limit as n approaches infinity. All of the x's except for 1 cancel, so you're just left with a single x there because you have one more in the numerator. That's n times n minus 1 times n minus 2 all the way down to 1. This is n plus 1 times n minus 2 all the way down to 1. Everything is going to cancel here in the top. You're going to be left with just an n plus 1 in the bottom. Okay? And now if you look at the limit of this as n approaches infinity, this is going to go to 0. Okay? The point I wanted to make here is this whole thing goes to 0. Remember, the limit needs to be less than 1 for this to be a convergent series. What this tells you is this value is always going to be less than 1 because that limit is always going to be 0. Okay, it doesn't even matter what x is here because it's being multiplied by a 0 as you get infinitely far out. Okay, what this tells you, this is actually going to be convergent for all real values of x. Okay, there is no value of x that would make this not convergent. Okay, you may also see a flip side. If we'd had a limit where I had like an n plus 1 over 1, then as n went to infinity, this would go to infinity, and you could end up with something where every value was going to be greater than 1, except maybe where x was equal to 0. So it is possible that it never converges, or that it only converges when x is equal to like 0. It is also possible that it always converges, and this is a case for the e to the x series where it's going to be convergent for all values of x.